In this video, we will have a brief look at the concept of differentiation. This is mainly for students of physics who need to have a brief idea about differentiation so that they are able to understand concepts of physics. So this is not meant for math students. We are not going to study differentiation in detail. Just have a cursory look at this concept. The concept of differentiation is associated with the concept of a rate of change. So let us say we have a function y is, let us say, x square plus 2. In the language of math, we say y is a function of x. That means y depends upon x. Y is the dependent variable, x is the independent variable. As we keep on changing the values of x, we will get different values of y. For example, if I take x equal to 0, I'll get y equal to 2. If I take equal to 1, I'll get y equal to 3. And so on. If I take x equal to 4, I'll get y equal to 18. And using these values, I can plot a graph of y versus x. So let us say we get a graph of y versus x. And this graph for this particular function, let's say is something like this. Something like this. It may not be exactly like that because for x equal to 0, you will have y equal to 2. So it would begin somewhere from here. So let me show it like this, something like this. And as I said, I'm not interested in checking whether this exactly graph matches with this or not. Our idea is to understand the concept of rate of change over here. So let us say the graph comes out like this. Now we are interested in finding out the rate of change. Rate of change in what? Rate of change in y with respect to x. So how fast is y changing with change in x? So for doing that, what we'll do is we'll take up two arbitrary points. Let us say point A and point B. And let us say their coordinates are x1 and this is y1 and this is x2 and this is y2. So the coordinates of point A are x1, y1 and coordinates of point B are x2, y2. And if I complete a triangle like this and call this point C, I can very clearly see that the change in y, that is y2 minus y1, is equal to bc, and the change in x is x2 minus x1, which is ac. So the rate of change in y with respect to x will be equal to bc over ac, that is y2 minus y1 over x2 minus x1. So this gives me the change in y for unit change in x, that is the rate of change in y with respect to x. And in the language of math, this is denoted by delta y by delta x. Delta represents, the symbol delta represents change. So change in y with respect to change divided by change in x. Now let us say we draw a line between joining these 2 points. So let us say I draw a line joining these 2 points like this. Now let us say the angle that this line makes with the x-axis is theta. So this angle will also be theta, and tan theta will be bc upon, I'll write over here, tan theta will be equal to opposite side upon adjacent side, bc upon ac. Thus this bc upon ac, this rate of change in y with respect to x, is also equal to tan theta, and this tan theta is known as the slope of the line. Slope of the line. Please note that this tan theta is the slope of this line. It is not a slope of the curve AB. We have drawn a line passing through A and B. So this curve is different. The slope of the curve keeps on changing. But between point and AB, when I draw this line, this will give me the slope of the line tan theta, and that will be equal to also rate of change in y with respect to x. Now this rate of change is the average rate of change. Why do we say it is the average rate of change? Because we have taken two distinct points AB and find out the change over this distance, not distance, but over this interval AB. So therefore, this is the average rate of change in y with respect to x. Let us say we are interested in finding out the instantaneous rate of change in y with respect to x. If we want to find out instantaneous, then what should happen is these 2 points A and B should be very close to each other. For example, we could have those 2 points over here. A could be over here and B next to it. So they are so close to each other that the change gives us the instantaneous rate of change. So if I draw these 2 points over here, let us say these are the 2 points. These 2 points are very close. I am kind of zooming into these 2 points. So they will be like this. And if I draw the triangle again over here, this is delta y, this is delta x. Now these 2 points are very close to each other. Therefore, delta y will be extremely small, and delta x also will be extremely small. In such a case, in math, delta y is denoted by, or we use the symbol dy for that, not delta y. Similarly, for delta x, we use the symbol dx. Using d indicates that change in y is extremely small. The word that we use is infinitesimally small. Similarly, instead of delta x, when you use dx, you're trying to communicate that the change in x is extremely small, because these 2 points are extremely close to each other, and that is because we are trying to find out instantaneous rate of change. So this instantaneous rate of change in y with respect to x is dy by dx. dy by dx. And this instantaneous rate of change is nothing but differentiation of y with respect to x. So when we find out dy by dx for any relationship between y and x, basically we are finding out instantaneous rate of change, and that is basically differentiation. Now the question is, how is it useful in physics? So let us try to take an example. Let us say we take ds by dt, where s is displacement and t is time. So this is a relationship between displacement and time. For example, this relationship could be s is equal to half gt square. So this is a function of, s is a function of t, g is constant, you know that. So s is half gt square. So if we get to find out ds by dt, what will this give us? This is instantaneous change, or instantaneous rate of change in y with respect to x. Or I could have simply have written instantaneous change in y with respect to x, or rather t, or in this case instantaneous change in s with respect to t, because we have taken ds by dt, instantaneous rate of change in s with respect to t. And what is this? Instantaneous change in displacement with time is nothing but instantaneous velocity. So by using the concept of differentiation, I am able to find out instantaneous velocity if I know the relationship of s and t. Let's look at one more example. Let us say we have dv by dt, where v is velocity and t is time. So this will be instantaneous change in velocity with respect to time, and that is nothing but instantaneous, as you would know, instantaneous acceleration. Thus, this is one more example of how we can use differentiation to find out acceleration. And there are many such examples in physics where we can use the concept of rate of change or differentiation. In the next video, we will look at the math aspect of this and try to study some formulae which we can use directly for finding differentiation. For example, if there is a relationship like this, y is equal to x cube plus 7. So this is a function of y is a function of x. So how do we find out dy by dx from this? So we will learn formulae to help us do that. We'll discuss that in the next video. Thank you.